Hello everyone. This is a severe storm spotting class for 2020 for Northeast Wisconsin. My name is Phil Karimsky and I am with NOAA's National Weather Service in Green Bay, Wisconsin. You can find us on the internet at weather.gov/grb and on Facebook and Twitter at the handle NWS Green Bay. We're going to go over a little bit of an overview of what the role of the National Weather Service is in Green Bay. As far as who we are, well, we're part of NOAA, which covers the sun to the sea. The National Weather Service covers the United States of America. In Green Bay, we cover our corner of northeast Wisconsin, which you can see on the map here, highlighted in black. Now, as far as what we do, we issue daily weather forecasts, as well as hazardous weather warnings when needed, and we provide decision support to our local partners, as well as public education and outreach. We do this in person events and on social media. Now, as far as when we're open 24 hours a day, 7 days a week, including all holidays. Now, we collect current observations, local reports, that includes reports from you, and we analyze forecast model data to make our forecast. Now, we do this because we want a weather-ready nation, because a weather-ready nation is better prepared for extreme weather, water, and climate events. And that is the main reason why we are here today. Now, weather spotters are part of keeping our community safe. In other words, they help create a weather-ready nation. So your role as a weather spotter is to report your weather to us at the National Weather Service. Now, this presentation will be fast-paced and we'll discuss how the importance of storm spotters are to the weather-ready nation concept. We will then step through a simulated event, giving you a feel of how a severe weather event might evolve. And of course, we also include important safety information. At the end of this course, if you'd like more information, including an in-depth meteorology and radar training, you're encouraged to take many online courses available to the public at our website, weather.gov/grb/skywarn. This website will also be available at the end of the talk, as well as additional links to get training. Now, are you weather ready? The main reason we ask that is because since 2010, we've had over 3,200 fatalities and over $100 billion in damages from things such as tornadoes in 2011. We've had many recent historic U.S. floods, Superstorm Sandy. We've had drought and wildfires, and we've had devastating blizzards recently. In Wisconsin alone, we've had $360+ million in damage, 50+ fatalities, and over 150 injuries. Some of the events are the record April outbreak in 2011, the Fox Valley tornadoes in August 2013. We had those heat waves in July of 2012. We had massive flooding in northwest Wisconsin in June of 2016. And of course, we've had the April 2018 blizzard that affected much of Wisconsin. Last year in 2019, here is a map of the billion-dollar weather and climate disasters. So as you can see, it affects the entire United States of America. So our mission is to help our nation be more resilient to increasing extreme weather, water, and climate events. One of these recent events was the Moore, Oklahoma tornado that happened on May 20th, 2013. As you can see, this is a picture of a medical center that was pretty much devastated by this EF5 tornado. So the Moore Medical Center took a direct hit by this EF5 tornado, practically destroying it. Inside were 30 patients and staff, but also 250 to 300 extra people from the community were inside seeking shelter. Despite this EF5 tornado practically destroying the building, everyone survived. And the reason for that was the medical center had a plan in place in case of a tornado. They worked with the community to assess the threat the day prior to the tornado. They had multiple ways to receive updates during the impending severe weather outbreak. They practiced moving patients and they knew where their shelters were in the hospital for tornadoes. How can you be part of a weather-ready nation? Well, becoming a weather spotter is a start, but you also need to have a severe weather safety plan for home and work. You need to talk about what you learn with friends and family. You need to have multiple ways to receive weather information, including a NOAA weather radio, your local media, or weather app for your smartphone. Do not rely on outdoor sirens alone. Those are mainly for people who are outside and cannot get to these other ways of getting information. Now, if you want to help spread the word and become a Weather Ready Nation ambassador, you can visit this website, weather.gov/grb/weather-ready. Now, if you become an ambassador, you can serve as an example by educating employees on workplace preparedness. You can promote Weather Ready Nation messages and themes, and you can share success stories of preparedness. As far as why we need storm spotters, well, technology has its limitations and the Weather Service cannot do it alone. Storm spotters can monitor the local weather, they can add credibility to our warnings, monitor storm trends, and watch for any unexpected changes. Our Doppler radar does a great job of viewing what's going on in a storm and telling us what might be happening. So at a local Weather Service office, we have electronics technicians that maintain and calibrate the radar, and meteorologists at the office scan what's going on in the clouds. We have a Doppler radar, which is a 10 centimeter electromagnetic wave that's transmitted at the speed of light, and it comes back and listens to whatever the beams hit in the cloud. So these radio waves strike hydrometeors, such as rain, hail, or snow, and then the energy backscatters back to the radar and it listens, and based on what comes back to the radar, it can give us an idea of what might be happening in the cloud itself. The Doppler radar can detect things such as reflectivity, which is how much stuff it's hitting, and that tells us where the rain, hail, and snow is located in the thunderstorm. The Doppler radar also detects velocity. This detects objects that are moving towards and away from the radar, and this helps us determine where tornadoes might be forming. We also have dual polarization that can be used to determine the shape of hydrometeors or other objects such as rain, hail, snow, and even debris. And the way this works is a pulse is sent out horizontally and vertically, and whatever comes back, it tells us the proportion of horizontal to verticalness that the object is. So, for example, a hailstone would be very little difference between the horizontal and vertical pulse because hail is nearly spherical. So based on that, it gives us kind of a guess at what might be in the clouds as far as precipitation type. And the radar can also detect precipitation and give us an estimate on how much rain has fallen in the area, which is really useful, especially when there is no ground observing network underneath the cloud at that location. Now, when you use radar, you want to use it with caution because it takes experience to interpret. Now, you can use radar to watch for development and to track storms and intensity. There are many web and personal computer smartphone applications available where you can view Doppler radar. We have many universities, private weather companies, and National Weather Service websites where you can view this, and also special software viewers. The Weather Service does not endorse any of these, but if you want to check them out, feel free to do so. Now, one of the reasons we want you to use radar with caution is, here's an example here from southwest Wisconsin, in Minnesota and Iowa, where we had several storms that were on the Doppler radar. One of these storms is producing a tornado. Can anybody take a guess on which storm would be producing a tornado? Would it be the storms in area A, B, or C? If you guessed C, you are correct, and if you didn't, don't feel bad because it's kind of a trick question. You can't tell just by looking at the radar in this kind of event which storm will be producing a tornado. So let's say you're watching this storm on radar. You have friends at 4 locations noted below. So who's best likely to see a potential tornado if one was forming? Would it be person A, person B, person C, or person D? The person who would have the best view at any potential tornado would be person D. Person A and B are in the precipitation shield and have a lot of precipitation that would be blocking them from a potential tornado. Person C also has the same problem. They have a lot blocking them even though they're not in the precip shield. Person D can see where the mesocyclone is, which is located right about here. So any potential tornado would form in this general area, and person D has a direct line of sight into that area where a potential tornado might be. So this is a great example of how technology and people can work together to help save lives. Storm spotters provide real-time observations and weather reports, and then the Weather Service uses that information when making local warning decisions. So now we're going to step through a severe weather event from a spotter's perspective, including how to get information, what to report, and how to stay safe. Several days before we have a severe weather event, we'll issue something that's called an outlook. Again, several days in advance, you get a general outlook of what's expected in what area that we're looking at. So in this example, you might hear something like the Weather Service is expecting possible severe weather out in the western Great Lakes region sometime early next week. The Storm Prediction Center issues severe thunderstorm risk categories based on the threat. So to the far left, if they're expecting just general thunderstorms with no severe weather expected, you might get maybe winds to 40 mile an hour or small hail. A category up from that is a marginal threat for severe weather. That basically tells us we're expecting isolated severe thunderstorms are possible. A slight risk means scattered severe storms are possible. Up from that is an enhanced risk. That means numerous severe storms are possible. A category up from that is moderate risk, where we expect widespread severe thunderstorms that are likely. And the highest of these is a high risk. We're expecting widespread severe storms across a large area. And as you go from left to right, the threat becomes higher. We're expecting more widespread severe weather. We're expecting the event to become longer lived, and we're expecting it to be more intense, with more of a possibility of a tornado outbreak or a derecho. So when you hear about the Storm Prediction Center thunderstorm risk categories, please keep these specific categories in mind when assessing your threat. The National Weather Service in Green Bay will issue specific tweets, things with social media, and other products from our office, which will highlight the threat that is specific to Northeast Wisconsin. So in this example, we issued a tweet saying we had storm chances that will increase tonight and linger into Sunday. Strongest severe storms possible Sunday afternoon. So if you follow us on Facebook and Twitter at our handle NWS Green Bay, you can get these alerts for Northeast Wisconsin and be advised of any threat that may be coming to our area. You can use the internet as well as apps. You can use weather websites such as weather.gov. There's many apps on your smartphones as far as other weather apps that are available, probably pre-downloaded with your phone or on your Google Play or Apple Play Store. There is an app from FEMA where you can get alerts from the National Weather Service for up to 5 locations. You can also get safety reminders and locate open shelters if you have a particularly bad severe weather event where you need to find a shelter. You can also upload and share your disaster photos to help first responders. Again, I mentioned the weather.gov/GRB website, and this is really handy if you want to find hazardous weather outlooks, watches and warnings, severe weather maps and forecasts, technical discussions of what we're expecting, radar and satellite imagery, storm spotter resources, and much more. And again, all these products are issued by the National Weather Service in Green Bay, so you're getting our latest thinking as well as any impending hazards for our area. You can also use broadcast media to get your information. And again, this is your personal preference and anybody you choose to follow. Just make sure you tune into that channel when severe weather is imminent or occurring. When you use NOAA Weather Radio, we issue a local hazardous weather outlook. Now you'll notice it provides a heads up to spotters. It's issued twice daily and is basically the next 7 days of weather impacts. So in this example on the bottom right here, in this hazardous weather outlook, you notice on the bottom, we tell spotters that we are asking them to contact us if hail reaches 1/2 inch or larger. So this is kind of the spotter's call to action. This is where we'll tell people what we want them to do and how we want to get the information. So you can also read this hazardous weather outlook on our website at weather.gov/grb/HWO. Now, can you name 3 ways you can get weather information about an upcoming severe weather event? I'll give you a moment to think about it. So 3 good ways to get this information would be from the internet at weather.gov, social media, television, or radio. Again, your personal preference on where you'd like to get this information. So let's say the day of the event you're aware that the Storm Prediction Center and the Weather Service in Green Bay are calling for possible severe thunderstorms later this afternoon. The threats include high winds, damaging hail, and a few tornadoes. Now before we get any kind of severe weather, we need a thunderstorm. In order to get a thunderstorm, we need 3 main ingredients: moisture, instability, and some sort of lifting mechanism. In order to get a severe thunderstorm, we require an extra ingredient, which is called vertical wind shear. Now when we want to cook up a storm, again, our first ingredient is moisture. The main source of our moisture comes from the Gulf of Mexico. Another ingredient we need is some sort of lifting mechanism. So you can get lift from several different ways. One is convergent from a low pressure system. Another would be convectional from local heating. You can also get orographic, which is basically a barrier like a mountain. Or you can get frontal lift, such as a cold front, a warm front, or even a lake breeze boundary. That could also be a source of lift for any convection. The instability or push is generated by the sun. Generally, warm air rises and cold air sinks. So the surface acts like boiling water. So the time when instability is maximized typically is 2 to 6 p.m., which also coincides with when we get most of our thunderstorms. Now I talked about the extra ingredient, which was vertical wind shear. Now what happens here is, in order to get a rotating updraft, you need some sort of vertical wind shear. So let's say you had a fairly light southeast wind at the surface, and up above you had stronger westerly winds. So what happens in this scenario is you get some sort of wind shear or rotation in the horizontal that just happens because you have different wind directions and different wind speeds occurring at different levels of the atmosphere. Now if you look at this storm to the bottom left, what happens is it takes this horizontal wind shear and a thunderstorm updraft will actually suck this up into the main thunderstorm. And when you suck up this updraft, it goes from horizontal to vertical. If you look at the bottom right, if it gets up there fast enough, it kind of creates a faster spin, sort of like if you were an ice skater spinning with your arms out and you brought your arms in, you would spin faster. Same kind of concept. You're taking this wind shear, which is kind of diffuse, then it's horizontal, sucking up into the updraft vertically, and if it sucks it up quick enough and contracts it enough, you can get a mesocyclone and possibly a tornado.
The National Weather Service has issued a tornado watch for the following counties in northeast Wisconsin: Brown, Calumet, Manitowoc, Door and Kewaunee. The watch is in effect until 5 p.m.
So let's say later that day a tornado watch has been issued. Basically what we want you to do in this scenario is to watch out for severe weather. This means that conditions are favorable for severe weather to form shortly or maybe a few hours into the future. So again, if we look at our map, we talked about the outlook already, which is issued several days in advance. When we issue a watch, that's generally a few hours in advance. It is more specific with the threat, area, and timing. So when a watch is issued, it may be issued for a portion of Wisconsin or most of the state, whereas an outlook would focus maybe on the entire western Great Lakes region. So our area of focus gets smaller as the event gets closer. Now remember, a watch means conditions are favorable for severe weather to develop. While it may not be happening right now, it may develop rather quickly. At this point, it is very important to have a plan and stay up to date when a watch is issued. Now we'll go over some tornado facts. A tornado is basically a violently rotating column of air that is in contact with the ground. Wisconsin tornadoes, we average about 23 per year. In 2019, we had 28 reported. In the last 15 years, our totals have ranged from 4 in 2012 all the way up to 62 back in 2005. June and July are usually the most active months, with central and southern Wisconsin the most active part of the state. Only about 5% of severe storms in the state produce tornadoes. As far as where the tornadoes happened in 2019, again you can see we had 28 tornadoes, and the strongest one was an EF3, which happened on September 24th near Elk Mound in Dunn and Chippewa counties. And again, that would be out in this area here. Now we did have back-to-back outbreak events on July 19th and 20th across the northern half of the state with a combined total of 15 tornadoes. There was a tornado on the east side of Green Bay on August 7th, and this is the first one since 2004 in Green Bay and in 2005 for the Green Bay metro area. One of the bigger events we had was the blowdown on July 19th. Basically, we had a line of severe thunderstorms that moved across much of central, north central, and eastern Wisconsin during the evening hours. We had widespread tree and power line damage from central Wisconsin into the Fox Valley and Lakeshore. Wisconsin Public Service reported over 50,000 outages during the height of the storm. The worst damage was associated with a macroburst, or a large downburst of straight-line winds that affected a large swath from Pelican Lake in Oneida County, southeast through Langlade and Oconto counties. There were also 3 tornadoes across central and north central Wisconsin. Here is the path of the blowdown. So as you can see, we had an area, again basically from Oneida County all the way through Oconto County. We had the heaviest damage here in Langlade where we had 90 plus mile an hour winds. Here is our radar loop of the event. You can see a storm was ahead of this main line, and when it gets incorporated into the main derecho back upstream, that's when things really get intense. So again, we have this lead storm and then this back storm here. It gets brought into this main line and a huge circulation develops, and this is when you get your swath of damage. So again, I'll let it loop again, and here's where the damage occurs, right through this area here, right after the storm gets incorporated or the storm merger happens. Now when we rate tornadoes, we rate them on the Enhanced Fujita scale. We rate them from EF0 all the way up to EF5. So again, a weak tornado generally is winds up to 85 miles an hour, and the EF5 would be winds over 200 miles an hour. As far as Wisconsin goes, 95% of our tornadoes are EF0 to EF2, so they're generally weaker or moderate strength. Here's everywhere where tornadoes have been cited from 1950 all the way through 2014. As you can see from the map, much of Wisconsin has received tornadoes. There's not really any safe area that you can say you'd be safe from any tornadoes. And again, you can see a lot of long tracks that have happened throughout our history. But again, the point here is every place in Wisconsin has basically had a tornado at one time or another. And again, northeast Wisconsin, if we zoom in a little bit, again, we've had a lot of tornadoes in northeast Wisconsin, particularly east central and central, but we've also had some in north central Wisconsin. We know we can also get variations of tornadoes, such as tornadoes without funnels or funnels that are not touching the ground. So you can see from these two images here, even though the funnel doesn't come all the way and touching the ground, if there's a ground circulation, that is indeed a tornado because it is a rotating column of air in contact with the ground. We can also get multiple vortex tornadoes, which happens when you have multiple vortices spinning in the same tornado. In addition, you can have tornado lookalikes, such as rain shafts, hail cores, or virga that can look like maybe funnels or maybe a tornado that is on the ground. However, you will note with these phenomena, they will not be rotating and they will not be persistent in the same area like a tornado would be. Some other lookalikes you can have are low clouds or scud. And again, these will generally not be rotating and will not have a laminar shape to their funnel. These will often be transient and will kind of move around, and they can look kind of nasty, like they might do something, but again, the cone won't be laminar and it won't be rotating in the same direction, and you won't have that debris on the ground that's swirling. You can also have a gustnado, which is a ground-based circulation. It is not a tornado, but it can produce minor damage. You can also have cold air funnels, which indicates you have very weak rotation. Generally won't have a wall cloud, and it could produce a weak radar echo. So a quick quiz question here. True or false? Tornadoes occur only in the summer months. The answer here is false. Tornadoes can occur any time of the year. And in fact, as of 2020, the only month which has never seen a tornado in Wisconsin is the month of February. Another quick quiz question. True or false? If you see clouds near the ground that are not rotating, you should report a tornado to the National Weather Service. The answer here would be false. A tornado is a violently rotating column of air in contact with the ground, so you would not call this in to the Weather Service as a tornado. Now you're on the field, there are visual clues to storm strength. You want to identify storms with strong and sustained updrafts. That'll help you identify potentially severe storms. Remember, the stronger the updraft, the stronger the storm. When you're looking at the main storm tower, you want to see a hard and crisp looking main storm tower. This is indicative of a strong updraft. If your main storm tower is soft and fuzzy in appearance, this is an indication of a weaker updraft. If you see a flanking line, this means that you have towering cumulus extending south or southwest of the main storm tower. This indicates you have updraft organization, which is necessary for persistent severe weather. A rain-free base is a location where the updraft enters the storm and can help you identify the inflow or updraft area. The area of the rain-free base just behind the rain is the preferred area for wall cloud and tornado formation. A shelf cloud is a wedge-shaped cloud on the leading edge of the storm. This is indicative of a downdraft area and possible strong straight-line winds. A wall cloud, on the other hand, is a lowering of the rain-free base, is near the rear of the storm, and is in the updraft area or the inflow cloud. If this is persistent, keep an eye on it and watch for rotation. Now, a wall cloud does not guarantee severe weather, but it does indicate the location of the strongest inflow. However, a rapidly rotating wall cloud means you are likely looking at a severe storm. If a tornado were to form, it would likely lower from the rotating wall cloud. Now, this is not a guarantee. Less than 20% of rotating wall clouds produce tornadoes. Now let's go over the difference between a wall cloud and shelf cloud, since these seem to be the two phenomena that most people get confused with. When you have a wall cloud, it's basically an inflow cloud. Air is flowing into the storm. An outflow cloud, on the other hand, your air is flowing out of the storm. The wall cloud is an area that's going to be in the updraft area. The shelf cloud is going to be where the downdraft is occurring. The wall cloud is near the rear of the storm or the rear flank, whereas the shelf cloud is near the front of the storm or the forward flank. A wall cloud is the favored location for tornado formation, whereas a shelf cloud, tornadoes are very rare. In the wall cloud, you could have strong straight line winds possible nearby, and generally the wind will be at your back. A shelf cloud, you have strong straight line winds that are likely, and if you're looking at the shelf cloud, the winds will most likely be at your face. Now, if we put all of this together, here's a schematic of a strong thunderstorm and supercell. So as you can see here, on the left-hand side, there's your flanking line. That's where new cloud formation is occurring. You can also see a backsheared anvil, which means the main updraft is so strong, it pushes air against the mean flow. The mean flow here is from left to right. So the updraft is so strong, it pushes clouds against the wind, kind of like upstream. If you look underneath, these are everything to the left of the main storm tower is where you have updraft. So your rain-free base is going to be underneath your updraft here. Now the updraft of a strong thunderstorm or supercell generally rotates. And again, this you can see that as you can see the striations in the main storm tower. Also, the updraft is so strong, you get an overshooting top, which punches through where the air is generally stable, which is where the anvil is. To the right is your forward flank or downdraft area. This is where you're going to get your rain and your hail, and also where you're going to get your forward flank shelf cloud. Underneath the main storm tower that's rotating is where you can get your wall cloud. And again, this generally occurs near the main interface of the downdraft or rain area and the updraft area. Underneath that is where you can get tornado development. And also to the south of that, you can have your rear flank downdraft, which wraps around the main mesocyclone and creates the hook you'll see on Doppler radar. So we put this all together. This is generally what a strong thunderstorm or supercell looks like. So you can tell the difference if you're looking at a wall cloud or a shelf cloud. Now remember, lightning can strike up to 10 miles ahead of a storm. So we tell people when lightning roars, go indoors. We want you to stop all activities, seek shelter in a substantial building or hardtop vehicle, and wait 30 minutes after the storm to resume activities. If you would like more information about lightning safety, visit our website at www.lightningsafety.noaa.gov. No place outside is safe during lightning, as you can see from these streamers that occurred in a golf course. So in order to be safe from lightning, generally we want you to get inside a sturdy building or hard-covered vehicle immediately. Now a vehicle is safe because it acts as a Faraday cage. When lightning hits it, it disperses around and goes to the ground. A vehicle is not safe because of the rubber tires. It's because it disperses around and is discharged to the ground. Now, if your car is hit by lightning, do not touch things that are going to the outside, such as your radio. If you have a ham radio or any kind of thing that's hooked up to an antenna, do not touch that either, as it could be a conduit to the outside lightning. Now, generally, we tell people if you can hear thunder, you are close enough to be struck by lightning. So again, we say if thunder roars, go indoors. We also want you to stay away from windows as well as plumbing, such as bathtubs and sinks and electrical equipment. If you are caught outdoors, stay away from tall objects, trees, and open water. Now when we get closer to an event, say within 10 to 60 minutes of a storm hitting you, you will issue something called a warning. And again, this is very specific in threat area and timing. So if we go back to our map on the left here, several days in advance, you get an outlook for a broad area. Several hours, you'll get a watch for a smaller and more specific area. And then when the event is imminent or occurring, we'll issue a warning, which is generally the size of a county or smaller. Now keep in mind, if a warning is issued for your area, this means take action now. The threat is occurring or imminent. This is the time to execute your severe weather plan. So remember, a severe thunderstorm warning means we're expecting hail over 1 inch in diameter or larger, and or winds over 58 miles an hour, and or possible tornadoes. If a tornado is spotted or rotation is seen on radar, a tornado warning is issued. Now, tornado warning may mean other severe weather hazards are present. So even though we issue a tornado warning, that doesn't mean you don't have to watch out for hail. Now, a severe thunderstorm also means you could have heavy rain and possible flooding. Now, the impacts from a severe thunderstorm are very dangerous and potentially life-threatening, especially if action is not taken. This can produce damage to property, as well as trees, power outages, and road closures. NOAA Weather Radio is the official voice of the National Weather Service. In this, you'll see forecasts, observations, hazardous weather outlooks, as well as watches and warnings. NOAA Weather Radio broadcasts 24 hours a day, 7 days a week, is portable, and if you have a battery backup, you can always get information even if your power goes out in your house. Again, it will alarm when urgency is needed, and it can save lives. And the good thing about the weather radio is even if the cell network goes down, as long as the weather radio is still transmitting, you'll still get these life-saving alerts and will not have to rely on the cellular networks, which may be overloaded or may be down due to severe weather. Hail indicates how strong a storm is. The stronger the updraft, the larger the hail. It's kind of a 1-to-1 ratio because it takes a stronger updraft to make larger hailstones because the larger hailstones require more lift to keep them aloft. Now, large hail can coincide with tornado activity. And about 35 of Wisconsin's severe storms produce large hail. Now, large hail can cause serious injuries and damage, and it's the costliest weather element in the U.S. with over $1 billion in damage to crops and property each year. If you are in an area that might experience hail, the way to be safe is to go inside. A substantial structure and overpass can provide the best protection. Stay away from windows because wind-driven hail can break glass. And as far as a vehicle goes, you want to avoid large hail. Your car will provide some protection from small hail under golf ball size. However, anything over that can produce hail damage to your windshields, possibly crack them, or even take it out completely. When you report hail, please measure the hail when it is safe to do so. Generally, this is not while the hail is falling. We want you to measure the hailstones at the longest width. Otherwise, you can use coins or other known objects to describe the size. Avoid using marble size to describe the hail, as marbles come in all shapes and sizes. Report the size of the largest hailstone and tell us, was there any damage? Now, if you don't have a ruler handy when you have hail and can't measure the exact size, you can use known objects. So, for example, generally the smallest size hail we have is pea size, which is 1/4 inch. And otherwise we use coins, say penny size will be 3/4 of an inch, nickel is 7/8 of an inch. Quarter size is generally 1 inch. Now this is where we start to get severe weather because a severe thunderstorm is 1 inch hail or larger, or quarter size or larger. Above a quarter, you could have a $50, which is 1 1/4 inch, walnut or ping pong size, which is 1.5 inches, golf ball, which is 1 3/4 inches, egg, which is about 2 inches, pool ball, 2 1/4, tennis ball, 2 1/2, baseball, 2 3/4, grapefruit, 4 inches, and softball, which is generally 4 1/2 inches. Thunderstorms can also produce downbursts. These are downdrafts that produce straight line wind damage and are known as basically downbursts. So what happens is, up in the cloud you have evaporative cooling due to dry air aloft getting sucked into the cloud. As the downdraft accelerates downward, it hits the ground, and when it hits the ground it has to go somewhere, so it spreads out. Kind of like if you take a cup of water, spill it on your desk, and you watch it spread out everywhere. That's kind of the same thing that happens. Is your air, is the water in that cup. As you turn it over, it hits the desk, and then it spreads outward, and anything in its path it can produce damage to. For severe thunderstorm wind safety, we want you to go inside and move to an interior room on the lowest level when the storm hits. That's because you could have debris and falling tree limbs that can cause damage and break windows. If you're driving, pull over and take shelter next to a building if possible. After the storm, be careful of debris because glass, trees, and shingles can be around, and if you step on them, it could cause damage to your foot or you could trip over them. And again, do not touch down power lines because you don't know if they're active or not, and you could get electrocuted. And if somebody else is being electrocuted by a power line, generally not a good idea to touch them because then there'll be 2 people being electrocuted instead of 1. When you report thunderstorm wind speeds, please tell us, did you measure or estimate the wind gust? Many people will overestimate the wind speed. Please avoid using heavy or strong when describing the wind. And if you can measure the wind, that is a huge bonus because estimating wind is extremely hard. The general guidelines we talk about when estimating wind is a 30 to 40 mile an hour wind will cause whole trees to be in motion. 40 to 50 will cause twigs or small branches to start breaking. 50 to 60 miles an hour can produce slight structural damage and cause branches to break. 60 to 70 miles an hour can cause down or snap trees as well as structural damage. So again, our cutoff is generally 58 miles an hour. So if larger branches or you start getting structural damage starts occurring, that's probably a severe thunderstorm. And again, when you call, please tell us what was damaged and what was the nature of the damage. So a large dead tree probably takes less wind speed to cause it to fall than a very mature, healthy tree that happens to get uprooted or snapped in half. That would take a higher wind speed. So when you report thunderstorm wind damage, again, did the wind produce damage? And if damage occurred, describe what was damaged, the character of the damage, and the extent of the damage. So as I said earlier, you could tell us, well, a large, pretty much dead tree fell. That's probably not severe. It's probably a lower wind speed. Whereas if you said I had very large 4-inch limbs that were ripped off the tree due to the high winds, that's probably severe because it takes a higher wind speed in order to do that. So that's why it's very important to describe what was damaged when you give us your report. So a quick quiz question. If you saw this on the ground, what would you report to the National Weather Service? In this instance, you would tell us either walnut or golf ball size hail. So again, report the largest size hailstone. True or false, straight line winds can be as strong or stronger than winds from a tornado. The answer here is true. And we found that out July 19th of last year where the straight line winds cut a swath through north central Wisconsin. Flooding can be a potential killer. It is caused by heavy thunderstorm rains and repeat or training thunderstorms. Now, it can be a flash flood, river flooding, or street flooding. Generally, all types of flooding pose a threat. Now, last year in particular, we started getting a lot of lakeshore flooding, which is kind of a new phenomena in recent history for northeast Wisconsin. So some of the products you'll see when we have possible lakeshore flooding are a lakeshore flood watch, which means significant lakeshore flooding or erosion is possible in the next 12 to 48 hours. A lakeshore flood advisory means minor flooding or erosion is possible or occurring in the next 12 to 24 hours. A lakeshore flood warning means flooding and erosion is posing a serious threat to life or property is possible or occurring in the next 12 to 24 hours. Generally, strong and gusty northeast, east, or southeast winds are the most frequent weather associated with lakeshore flooding and erosion. Anytime you get any onshore wind component, that's generally when we have the highest threat for the lakeshore flooding or the lakeshore erosion. Some flooding safety tips: do not drive across a flooded roadway or a low water crossing, as vehicles can float in as little as 2 feet of water. Be especially cautious at night. Do not wade into floodwaters because you don't know how deep the water is, how fast it's moving, or what is in the water. You could have dangerous debris or downed power lines which could electrocute you. When you report flooding, any flooded roadways, rivers, or streams, you can approximate the water depth. If the water is standing or is it flowing? Is the water level rising, staying steady, or is it falling? And is there any damage due to the flooding? For tornado safety, we want you to go to your safe room. The safest place is the interior part of your basement. If there is no basement, go to an inside room on the lowest floor without any windows, such as a center hallway, a bathroom, a closet, or inside a bathtub. If you're in an apartment complex, work, or school, know where your safe place is beforehand. If you're in a mobile home, remember these are not safe in a tornado. Please have a plan for safe shelter beforehand. If you're in an apartment complex, you can make an agreement with someone on the lowest floor of your building to designate as a tornado safe place. You can ask the building manager if they have a tornado shelter or tornado plan. If not, please suggest one. Do not use an elevator. If the power fails, you will be trapped. Again, stay away from windows. If you're in a mobile home, do not stay in the mobile home. They are easily flipped and destroyed during high winds, even if they have a tie-down system. If there is a nearby building, set up ahead of time that you will go there in the event of a tornado. If there is no buildings, lay flat in the nearest ditch and shield your head with your hands. As far as schools or businesses, again, most schools or businesses are built to be stronger than a normal house, which can help protect you. If a tornado occurs while in school or at work, stay calm and listen, and calmly follow instructions. Move away from windows and glass doors into the innermost part of the building. Crouch down and protect your head. Leave your belongings. They can be replaced. If you're mobile and you see a tornado while in a vehicle traveling, pull over to the side of the road, get out of the vehicle, and lay flat in a ditch. Do not stay in the car or try to hide under it. Do not try to outrun a tornado. Tornadoes can move erratically and change directions. It is impossible to predict its behavior, and you could be driving towards danger instead of away from it. And do not hide under overpasses. When you report tornadoes, please tell us the time it occurred, the nature of the tornado. Was it wide? Was it lifting? Was it skipping? And was there a debris cloud? If you can, tell us how long it was on the ground, the distance and direction of the tornado relative to your location. For example, the tornado was northeast of my location, about 2 miles away. Any damage or the extent of damage and what was damaged. Again, more substantial structures or trees generally mean higher wind speeds than ones that are less substantial or, say, trees that are dead. Give us your report when it is safe to report. Quick and accurate information to the Weather Service is critical during severe weather. However, reports from spotters are used in real time to evaluate storm intensity, but we want you to stay safe. A late report is much preferred over an on-time report that puts you at risk. You can report to us anytime, day or night, since we are here 24 hours a day, 7 days a week. Please don't assume the Weather Service knows what is happening in your neighborhood. We rely on the eyes of our spotters to confirm what we see on radar and satellite. If you're an amateur radio spotter and the Skywarn net has not been activated, please call us on our toll-free line. Your accurate and timely reports are invaluable to us. Now, as far as what to report, any damaging high winds, about 40 miles an hour, and or any wind damage. All sizes of hail. Tornadoes, including funnel clouds and waterspouts. Rotating wall clouds, flash flooding, flooded roadways, deaths, injuries, or significant damage. The following reports are non-urgent but are helpful. Cold air funnels, dense fog that's less than a quarter mile of visibility, total rainfall, ice jams in the spring, river flooding over the banks, freezing rain, snowfall, or slick roads. Now, how to report snow? Basically, you measure in at least 5 locations, find the average, avoid measuring snow next to buildings as it can cause drifting, record the snowfall to the nearest tenth of an inch. When you send us a report, tell us who you are, where you are, the city, town, and county. You can be precise as possible with your location. If you have GPS, you can tell us the lat and long of where you are, and we can look that up. Tell us what you see, where the phenomena you witness is, again, distance, overhead, direction, when you saw it to the nearest minute, photos, you can send them through social media. Now we want you to report what you see, not what you think you see, what you want to see, or what you think you will see. The ways to contact us are through our online reporting system at weather.gov/grb/report. Again, this is for spotters and the public. You can contact us on social media at Facebook and Twitter at NWS Green Bay for both. And if you tweet us, please tweet to at NWS Green Bay or use the hashtag WIWX, which stands for Wisconsin Weather. If you're interested in contacting the Weather Service to be part of our network of rain, hail, and snow, which is called CoCoRaHS, you can join at www.cocorahs.org. If you join this effort, you can report daily rain and snow as well as severe weather.
This is trained storm spotter Linda. I'm calling to report thunderstorm wind damage 4 miles south of Rhinelander. The damage occurred 5 minutes ago and stripped some shingles off my roof. There are several branches down all over the street. The largest ones are about 6 inches in diameter off of healthy trees. I did not observe any hail with the storm. The power keeps blinking too.
Now this is an example of a good spotter report. And the reason it is good is they included the location, 4 miles south of Rhinelander. They included the time of the severe weather, 5 minutes ago. They included the damage, the extent, and the character. Stripped some shingles off my roof, several branches down all over the street. Largest are 6 inches in diameter off healthy trees. Again, they estimated the branch size, 6 inches in diameter. And they included that they are a National Weather Service storm spotter at the very beginning. Here's another example of a good spotter report. Again, this would be something like on Twitter or Facebook. So the person here included location, 2 miles south of Abrams off 41 and 141. Hail size, largest hail about 1.5 inches. They included their storm spotter, trained weather spotter. Included the time of the event, about 2:30 p.m. A bonus, they included a picture so we can verify that the hail is as large as they said it was.
Hi, this is Pete. I am a spotter north of Wausau. We have marbles falling from the sky and there's some heavy rotation with that storm too.
So this is an example of a bad spotter report. This person did not include their location, did not identify themselves other than to say that they were Pete. They said marbles. Well, we don't know how big a marble is. A marble could be 1/2 inch or it could be 1 inch. They said heavy rotation. We're not quite sure what that means. They didn't have any additional information. Can heavy rotation cause damage? We don't know. So again, the number one rule is be safe. Spotting can be dangerous. Storm spotting is important. However, our main goal is to keep you safe. safety first. Keep an eye to the sky, prepare for all hazards, watch out for lightning, and if you're mobile spotting, drive smart and safely. Remember, each storm and weather event is different. Storm spotting takes experience. The more opportunities you can to go out in the field, the better. Never assume the National Weather Service knows what you are experiencing because we value your reports. Tell us what you see. Please don't exaggerate. And again, stay safe. So, a quick quiz question here. True or false? You should not drive across a flooded roadway or low water crossing because vehicles can float in as little as 2 feet of water. Answer here is true. Never drive across a flooded roadway. True or false? The preferred method of sending us your severe weather report is the toll-free phone number. True. Name the most important things you should report when you call the National Weather Service. Please tell us who you are, type, location, and time of the severe weather. And again, a picture is a bonus. Well, thank you for sitting through this presentation. We appreciate your help during severe weather all year round. You can visit the Green Bay National Weather Service Skywarn website to download the Spotters Field Guide and for more information about the Storm Spotter program. Go to www.weather.gov/grb/Skywarn. Now we do have additional training if you would like. Again, we have the Green Bay Skywarn page, which is weather.gov/grb/Skywarn. We do have additional online training at this MedEd website. If you complete the 2 modules to receive full credit and email your certificates of completion to nws.greenbay@noaa.gov, you'll receive additional information on becoming a storm spotter for Northeast Wisconsin. Again, thank you for attending this via pre-recording. And if you have any questions, you can email us at nws.greenbay@noaa.gov.